Greetings, everyone. We'll begin in just one moment, I promise. Wait for everybody to get in here. Greetings, everyone. Welcome back to RIA Robotics Week. We hope you're enjoying this conference so far right now in logistics and warehousing, specifically as it relates to autonomous mobile robots. We have 8 great presenters today talking about their technology, their applications, their use cases. We have Matt Wicks, Chief Robotic Solution Architect at Honeywell Intelligrated. We have Nicolas de Keijser, Head of Sales at Boston Dynamics. We have Jason Walker, the CEO and co-founder of Waypoint Robotics. Rob Sullivan, President and CEO of Autoguide. Andreas Boedenauer, CEO of AGILOX. Josh Cloer of Muir. Karen Leavitt, Chief Marketing Officer of Locus Robotics, and Mark Messina, the Chief Operating Officer of the Americas at Geek. Welcome, everyone. And as I said, we are going to jump right into this, beginning with Matt Wicks. Matt, welcome. It's great to see you.
Thanks, Robert. Appreciate it. Thanks for having us. We've got a fantastic lineup, so we'll dive right in here. So we're going to talk about autonomous mobile robots and different use cases. So I'm going to start out some motherhood statements here. A lot of us in the robotics industry are very familiar with these, but it's the 3 Ds. Why robotics? You know, these are dull, dirty, and dangerous jobs that are out there, and we're looking at leveraging robotics to address these challenges. Dull is there's a lot of turnover with these positions, and we're looking at the leverage robotics to help lessen the monotony of the work that is being done in these facilities. Dangerous, the operators are very injury-prone jobs that are out there, and so we're looking to remove those operators from at least some of those positions and put them in a safer and cleaner environment. So the last bullet point here, the dirty environments, put them in cleaner environments, more humidity control, temperature control, nicer environments to increase the overall job satisfaction and productivity. So just a kind of just a general landscape here of logistics and robotics. Really, we've got a variety of different things that we'll talk about today. A lot of them will be hit in the presentations, but so the few that I'm going to be talking about: truck loading and unloading. So we're going to talk about a robotic loader, and then also talk about an articulated arm loader unloader. Robotic induction. So this is not a mobile robot, but its robots are used in the parcel industry for picking and placing parcels onto sortation solutions. Mobile robotics, again, what we're here today to talk about here is the AMR solutions. Lots of different opportunities here to leverage this technology in the logistics. And then last but not least, palletizing and depalletizing. A lot of the equipment that are inside of the facilities are brought in on pallets, removed, depalletized, and for that matter, even palletized. And so lots of opportunities out there. And then kind of pulling all these things together, these are integrated solutions. It's not necessarily just about the robot itself, but it's about all the entire solution and what we're looking to accomplish for our end customers. So let's talk about robotic unloading. This is our robotic unloader. It's a nice, decent machine that is designed specifically to unload autonomously tractor trailers and containers. So these are fluid-loaded trailers of a mix of different shapes and sizes and weights and stacking patterns. And the machine is designed to see those products and autonomously remove them and get them into the facility so they can be processed and received. And its intent is to get those operators out of that environment of that really hot trailer. If you've ever been inside of a trailer in the middle of summer in Phoenix, Arizona, it is a miserable place to be in. So the machine itself is comprised of a variety of different components. The end of arm tooling, the nose conveyor, we've got multiple different articulated arms, and all this sits on a mobile platform. So I might claim the largest mobile robot in this presentation today, but we'll see what the others present. So I'm going to go ahead and fast forward to this and play a video of this. So the basic operation here is that the machine, the operator opens the door to the trailer, uses a joystick to navigate the machine into the trailer, drives them in, goes back in, and hits the go button. And that go button basically enables the vision to find the products that are inside of the trailer, and then the machine makes independent decisions on how to go pick those products and discharge the products into the facility. So the other unique feature about this machine is not only does it pick the products, but then if the products are on the floor or they're dropped upon the floor, we can move the nose all the way down to the floor and sweep those products up off the floor and through the throat of the machine. And there's some patented technology that we use for collecting those items and then discharging it in. So it looks relatively simple, but there's a fair amount of sophistication and machine learning and AI that goes into understanding what's inside of the product, inside of the trailers, and how this machine performs. It's really designed for very simple use, but just like your iPhone, it's a really complex piece of machinery that's made very simply to use. I'll move to the next slide. So this is a variant of this machine. So this is another mobile robot, but it uses an articulated arm, and it is used for loading and unloading of trailers. So in the previous example is focused on unloading a variety of multiple different types of SKUs. This is designed to load very specific SKUs, specific widths and sizes of SKUs, and it can load and unload those products. So here's a video of this in operation. Well, maybe there's a video of this in operation. No, maybe not. So Robert, maybe you can help me out if we can get this video to play. There we go. Perfect, thank you. It's good to have friends. Yeah, so this machine, again, uses computer vision to find the products inside of the trailer. And then it autonomously then directs the arm to pick the products as they're coming in and then stack them. So essentially this is a palletizer on wheels for truck loading. Again, it's very fixed SKUs, but it does the loading of the trailers. It's also made to operate in reverse. So it uses computer vision to find those SKUs and then pick those products and then set them on the discharge conveyor and out to the facility for processing. Again, two different unique technologies on both mobile platforms that are designed to facilitate the loading and unloading of the trailers in the facilities. All right. So mobile robots. That's a little, there we go. Lots of different use cases in mobile robotics. So we go from handling each picking to handling put away to cross-docking, just-in-time delivery in work cells, handling recycled material and dunnage, removal from workstations. So there's just a variety of different opportunities to apply mobile robotic technology into facilities. So the robots that we're highlighting here use SLAM navigation to be able to map the facilities and be able to autonomously route themselves within the facility. And so that opens up multiple different use cases for the robots. So I'm going to talk about a couple of those right now. Maybe I will. There we go. So here's an example of leveraging mobile robots and AMRs to facilitate picking in aisles. So this is an operator that's doing picking to a cart. So this could be directed with a voice picking system or pick to light, multiple different ways to do this. So in normal operation, that operator then has to deliver those products, or they have to be conveyed to an external area for a pack out or maybe even a decanting. Here's an example of we're using an AMR to pick those carts up from the ends of those pick aisles and then save those operators the time of actually having to walk through those different areas. So I'm going to show, this is a video of, again, maybe I'm going to have to ask Robert for some assistance. Yeah, here you go. Okay, this works. So this is an example of the similar kind of technology, picking to carts, but instead of doing pick aisles, this is used for the returns process. So for instance, you can think of items coming back from returns into your facility, and they've got to be delivered to multiple different areas and sorted out too. Maybe some of these returns are going to go to trash and some of them are going to go to different areas, or go to re-inventorying. And so AMRs can be used to support the receiving operation and then delivering them to the specific areas. Here in the video, we're showing those AMRs delivering those items back to inventory. So now we receive them in, the operator places them on and directs those items to the back to inventory. The operator then pulls the cart out and re-inventories them and then sets the cart back down. What's this doing is it's keeping those operators in those workstations and increasing their productivity. They're not wasting time moving back and forth between the receiving area and the areas that they're supposed to be doing the replenishment work. Okay, I've got one more video here I'm going to show. Hopefully I can do this one. Thanks, Robert. So this is doing AMR transportation to work cells. So you can think about this as you're doing some value-added service, whether it's a pack-out connection to some kind of high-density storage or some kind of validation processes in individual work cells. And then those items need to be passed to secondary work cells or maybe even tertiary or multiple different work cells. So instead of having individuals have to cart items from work cell to work cell to work cell, we leverage AMR technology to be able to quickly route those products from those different work cells, leaving those individuals in their work cells to be able to perform those value-added tasks that the human operators can actually go do. It reduces the amount of time that they're wasting going between the different work cells. It also, it helps to address some of the confusion. So if you have specific routing to particular work cells, then you can, the software that's leveraged can specifically say if you need to take these items from work cell 1 to then 5 and then 6, the software is used to route those to those particular stations in that particular sequence. Whereas you might have to rely upon an individual to either know that or waste time trying to figure out where this cart's supposed to be routed to next in some kind of secondary process. So it not only just facilitates the increase in productivity, but it also facilitates improved quality in your overall processes. So I think I'm right at time. So I just want to appreciate you the time, and I'll pass it off to the rest of the team. Thank you very much. So this is Nick.
Matt, thank you very much. Had a little trouble unmuting there. That should be on the, oh, hold on. You guys hear me? Somebody nod your head if you can hear me.
Yeah. Actually, I think I'm a little bit under time too, so.
You are, you did very well in that regard. Right. Next up, we have Nicolas Keijser of Boston Dynamics. Nick, welcome. It's great to have you.
Thank you, Robert. Thanks, Matt, for doing the lead off on everything and actually granting me 2 extra minutes now. I'll try to pass on those 2 minutes to whoever comes up next. So Robert, just confirming everybody can hear me appropriately. Okay. Okay, great. So future of warehouse automation will be the topic of today. So I think I'll try to segue a little bit on what Matt was bringing up and kind of see like what more is possible and what is needed to be able to do more than that. So we can go. Try to the next slide. I do have control. A bit too fast. There we go. So what is current state of automation in DCs? I'll start with a couple of trends and statistics. Some of them are a few years old, but I think they're very valid still today to kind of assess where we're at in terms of robotic automation in DCs. And it was about 3 to 5 years ago, it was assessed only 10% of warehouses across the world would have some sort of robotic automation. And at the time, they would forecast that amount of robots would grow by 20 times, if not more, over a span of 5 years. And it certainly grew over those 5 years, but certainly not 20 times. And I think my colleagues on the call will probably echo that. We would have loved that, but it's not really materializing to that extent. But again, it has grown, and we'll look also at that. So it brings up the question, what is needed to really grow that automation? Because the need for it is clearly established. I mean, there's many reasons why we would like to see more automation in DCs and distribution centers. And if you look at that more in detail, and you look at what technology was implemented for, picking goods, cartons, that type of things into warehouses, you'll see a lot of those technologies so far were there to really support operators. And actual robotics which is the highlighted blue circle in the middle of the slide there, really is more limited in the marginal part of what was implemented at the time. There's several reasons to why that is, and we believe that perception, being able to see things with robots and mobility are two key attributes where robots still have, improvements they can make and get a lot better. There's other reasons, but those are certainly two areas that I would like to explore, and I'll do that in the next 10 minutes. And then finally, the opportunity itself is really large. If you think about DCs, more than 90% of distribution centers require some sort of case handling, where it's partial or complete, but there is just a lot of boxes that have to be handled separately and not just as a complete pallet. So just picking up boxes, whether it's to, and the applications are depalletizing, repalletizing, order picking, a lot of the things that Matt covered earlier. And those can be really complex, especially the last one, loading up trailers, getting things out of the DC again. That is really, really complex and a very harsh task. So what do we have today? I mean, the case picking automation in general has come a long way in the last 5 years. And there are existing applications today. We see quite a bit of single SKU layer depalletizers that have been deployed. If you go to warehouses, especially with high volume warehouses, you'll see some single SKU palletizing also in warehouses. It's pretty typical to see that in manufacturing today at the end of lines, but not so much in warehouses, but it makes its way. We definitely see some trailer unloading now. Matt showed that earlier. Number of things that maybe 10 years ago were not really, 5 to 10 years ago, were not the norm, are there now and are making their way. But they typically still have limitations in terms of there needs to be a certain structure. Their flexibility is limited. Some of these machines are fairly static. They require fairly large infrastructure and large footprint, which then often equals big dollar signs, big investments. So if you think about the real life challenges, just going on to the next slide here, that warehouses really have today, there's still some ways to go in terms of meeting those real operational challenges. And in terms of technology, so what we see is that those needs really translate into applications like mixed queue depalletizing, floor loaded truck load and unloading, mixed queue order building and palletizing. Again, these are the typical things we see. And while these type of applications were, how to say, they require too much variances. That's the word I was looking for. So there's this large variations of objects, a limitless combination of how a box could look like, and the processes also kind of tend to change within the warehouses. So these challenges, how are we going to address all these boxes? Not only can we see a lot of different boxes, we see that some of these boxes can be damaged, so that changes the way the system will look at it. And finally, want to also say that tight spaces. You look at some of the pictures here to the left. There's not a whole lot of space between where the boxes are, where the conveyors are, and square footage is always at a premium where it's in manufacturing warehouses. So you want to fit those tight spaces as good as you can. So that brings us to the technology part. And first thing I'd like to go over, going to the next slide here. Sorry. Little technical challenge. There we go. All right, there we go. So we got perception is really, I think, is a very important thing. If you think about operators, they go around a warehouse, they can see a box for what it is. They can see a rack. They can see very well. And for sure, in the last 2 decades, computer vision in general has done a lot to the industry and has enabled a lot of new applications, you know, starting with 2D vision and more recently 3D vision. 2D vision is already broadly used in manufacturing today. 3D vision, as I said, more and more is getting more robust. It's becoming more affordable. So those two, having those technologies is like a prerequisite almost to accurately locate things for a machine to see. But that's on and on itself is not enough to go with that big variation you find in warehouses, where you really want to find a solution to that. And that's where artificial intelligence or deep learning really comes into play. So this is really what adds to the vision and enables to deal in more unstructured environment, to deal with more cases, and also to allow a system to improve over time. So if it doesn't recognize something on day one, it will maybe the next day as it learns and gets changed. If the type of packages changes in a warehouse, if the structure in the warehouse changes, the system can adapt to that. And I think that is also very important to be able to overcome those limitations of always having the same environment at any given time, because that's, you know, unfortunately for automation is not the real life situation. So if I go a little bit more into vision challenges that you'll see to explain a little bit more where AI comes in. So, you know, the 8 pictures you can see here are typical pictures of a pallet looked from the top by a traditional camera. And you know, I'll pick up a couple of examples here, but if you look at that first pictures of mixed queue non-rectangular boxes. Well, so now the system is used to look for square objects, but now all of a sudden you don't have those. So how are you going to deal with that? Having a artificial intelligence layer can actually help define what those non-rectangular boxes are. Reflective tape can actually throw off a system by thinking that one box is actually 2 boxes. Again, the artificial intelligence can help filter that. We can make a difference between what is a box and what is a plastic wrap cans. When boxes are highly textured, same thing. I mean, where does a box start and end? Straps on a box are notorious to throw off traditional cameras. So again, deep learning is important there. Mixed SKUs, you have all kind of things in there. And then the final item, and I'll show a video of that later, is when you package things very tightly and you only rely on a 3D image, as is actually shown on the picture, the little red and blue picture, you would actually not see that those 2 boxes on top are separate boxes. For the computer, that's what the computer sees. He sees basically one big red line and he thinks that that's one box, and that would be a problem for a system to differentiate these things and then pick them independently. So, but let's have a look on how this works in real life. So this is a typical pallet that you could find in a grocery DC today. You can see a big variation of goods from cans to boxes, and not everything is stacked appropriately. So you need to be able to differentiate these things, make smart decisions on how to move them, because they may not, cans may not adhere to a gripper the same way than a box. So seeing those differences help. When a box is angled, you also want to make sure the robot knows that, so he can pick it up accordingly and doesn't crush it. So now you'll see the video accelerating a little bit. So we can make our way through the stack. And you want to be able to do all these things without pre-training, because you never know what's gonna come to the robot in terms of a depalletizing application. It could be anything. So that's where it's very crucial to be able to do that on the fly and identify and get the robot immediately based on what he gets. So as we're making our way down the stack here, you'll see that the last layer, that's actually a single SKU layer. But if you look at it from this viewpoint, you'll find that it could almost be like this could be one giant box to a camera. So you need to make sure you differentiate that these boxes are all singular boxes, and then make good decisions. So again, perception, as you can see, there was a lot of perception challenge here for cameras, and artificial intelligence will help there. So the other key enabler that we see in warehouse automation would be really around mobility. So if you think about a warehouse today, there's enormous amount of motion between network of conveyors, people walking through aisles, moving boxes around. So if you're going to introduce robots in that environment, it's only normal that you want to make sure that those robots have a certain level of mobility. And so I think previous presentation, Matt showed it very nicely with what you could do with AMRs, automated mobile robots, autonomous mobile robots. I mean, so those are making their inroads in warehouses today and moving packages along. You want to be able to load those AMRs. Maybe in some cases you want to be able to go to a conveyor. Maybe a robot wants to do several tasks. So having a mobile arm able to take different tasks on is certainly something you want to do. And then finally, you also look at like automated forklifts when you want to move pallets around, whether it's to load them in a truck, whether it's to move them around the warehouse, put them in the rack. So you have all these autonomous robots now that are mobile, moving around the plant. And so not only will you need to deal with the mobility, you also will have to deal with communications between all these devices. You want to make sure that those different type of robots that are going to see the warehouse can talk to one another, can know from one another where they are, where they need to meet. And so it's an important part to make sure that we can deal with that traffic, and also have all these robots talk with the warehouse management systems to actually know what to do and do that in a sensible way. So, and as a last, I have another video that I like to show right here, give you an example of how this could work with, we have, as Boston Dynamics, we developed the handle robot, being a mobile manipulator that could do various tasks in the warehouse. And in this case, we're showcasing how it interacts with an AMR, mobile robot, to prepare an order and move that pallet with the order across the warehouse. And if you look at this video in detail, you see there's actually a lot of things that needs to be between the robots that need to interact. The robot needs to know where that mobile robot is. The mobile robot needs to know now that he needs to move around so he can be palletized on the other side, because that's the most optimal way to do it. The arm needs to be able to perceive its rack and find where the robots are, make sure that he finds the empty spot. So there's a lot of that mobility, perception, communication going on. And these are areas where we're hard at work to solve those problems, so that a truly fully autonomous warehouse can become something of a reality in the near future. So thank you very much for giving me the opportunity to present this today. And I see that I was able to keep the 2 minutes that I got from Matt, and I hope and gladly pass it on to the next one up on the lineup. Thank you very much.
Nicolas, thank you very much. That was great. Next up, we have Jason Walker from Waypoint Robotics. Jason, welcome. It's great to have you here.
Great to be here. Thanks for having us.
Always a pleasure. Jason, you should have control now. Take it away.
All right. So here at Waypoint, there we go. So at Waypoint, we make autonomous mobile robots. And the objective is to empower the workforce that's already on the job. The people who know the business, know the products, know the people, know the facility, give them better tools that they can use to be more effective. And we had to make an exceptionally good robot to be able to abstract all of the technology so that shipping and receiving clerks and assembly line workers and machinists can all take this robot and put it to work right away. So we've been really focused on ease of use at that level. We have a lineup of robots. We have 4 configurations of Vector that can carry up to 600 pounds, 3D perception systems that make the robot behave in ways that are intuitive for people, which is exceptionally helpful in making them easy to set up and easy to work with. All of our robots have a 3-stage safety system, which is critical, of course. And and Mavic is, if you need a small car moved around, we can do that as well. All of our robots are omnidirectional, which is key to being able to quickly and accurately hit waypoints. There's an ecosystem of products that we needed to build to make these robots easy to use. Our dispatcher software is the tool that you use to set up the robot and configure and reconfigure them. Whistle is an HMI device that's built into dispatcher, and that's essential to be able to utilize, to have anybody be able to utilize these robots and not need to go to college for it. The end zone wireless charging system is key because you've got to be able to trust that your robots are going to get charged. And if you have to add to somebody's to-do list that they have to monitor the batteries and the charging and maintain electrical contacts and things like that, then you've given them more work instead of less. And so the wireless charging system is a key part of our strategy to make these things more robust, more reliable, and easier to use. The use case that I want to talk about today is with North Shore Care Supply. They're an e-commerce company that supplies medical supplies primarily to elderly folks in their homes, which, during the pandemic, we were cranking really hard to get these robots in their hands so they could meet a huge increase in demand. We partnered with our friends at the Numina Group who did the warehouse execution system, and they really glued together the warehouse management system with their voice picking system and our AMRs, and they were able to triple the output of the picking operation at this organization by using our mobile robots who can carry these 600-pound carts, or not carry them, they're actually towing them. Our Kingpin system allows users to either pick up a tote or hook onto a cart and pull it around, and it can do either one without having to change anything. You don't have to have a robot dedicated to one or the other. The throughput, they did a stress test on this, and they more than tripled their throughput on picking and completely shifted their production bottleneck from picking to somewhere else. And the outcome has been great for everyone. It's the perfect confluence of the application, the integration, and the AMR. Their workforce was involved from the beginning and received training. So any of the folks that are working with these robots and picking to these robots, they can set up the robot, reconfigure it if necessary, manage any kind of situation that will come up. And because they were involved through the entire process, they've really taken to the robots, and they see them as a tool that has been put in for them. If we're lucky, guys, we've got a video here kind of showing how this works. So we have a bunch of end zone wireless charging systems, and the robots cycle through there, and then here vector aligns to the cart. You'll see the crown, which is the receiver hitch, and the markers, which is how the robot uses the AI camera to locate itself relative to the cart, so the cart doesn't have to be locked in a perfect position. And then the robot tows this gigantic cart through the facility, and Numina Group did such an amazing job of sending the pickers and the robots to the same place at the same time and managing in the most intelligent manner how to do that. So it isn't like a picker walks with a cart. The cart goes where something needs to be picked, the picker goes where something needs to be picked, and after that, the cart might be dispatched someplace across the warehouse, and the picker might be dispatched 10 feet back to serve the next cart. So the load balancing is a huge part of this, and it's just been exceptionally effective. Once the picking is done, the robot drops off the cart in the picking station, and then the people who are packing boxes can get all of the product off the carts and get them moved through to shipping. And then the robot will either go grab another cart or it will go charge or whatever needs to be done next. Wow, that was fast.
We appreciate that. It might mean we actually finish on time, Jason. Thank you. Thank you very much for that. Again, if you guys have questions for any of these panelists, I doubt we'll get to them at the end of the session, but please put them into the chat. They can see them there. We'll also forward them ahead to each one of these companies. Jason, thank you again. That was great. We appreciate it.
Real quick, I always try to go through the slides fast because they're boring and leave room for Q&A because I'd rather just talk to people. So if anybody would like to talk to us, please drop on by our virtual booth. This is not a backdrop. That's a real robot. So we'd be happy to give you guys a demo. Thanks.
Great, Jason. Thank you very much. Next up, we have Rob Sullivan of Autoguide. Rob, it is great to have you here today.
Oh, thanks. So I have a lot. Jason left me a lot of time. I'll use the whole half hour.
Yeah. I don't think it works that way, unfortunately.
Oh, it doesn't work that way?
No. Hold on one moment here. Of course, here's where the technology fights with me. It's done really smooth. Hold, please, as they say. There you go, Rob. You should be able to see your presentation now. I'm going to give you mouse control here. There you go. Take it away, Rob.
It should be good. Let me see. Oh, I think I went too far with. Okay, today I'll be talking about automated storage and retrieval systems, and then where we're bringing it from an autonomous storage and retrieval system. But I think mostly the people on the call will be familiar with an ASRS. So I've been working in the ASRS world, started in storage and retrieval in semiconductor manufacturing. We were storing and moving around wafer boxes. And did that for a number of years, and then started up another company, co-founded another company. We were doing case storage and retrieval systems. I saw a huge need in the industry for pallet. Our systems we had before were large case pick systems, and we had a great need for autonomously bringing pallets to us and bringing us away. I saw a big void in the market for that. Didn't see any really great technologies to do that. But today, I'll be focused in on the ASRS portion and where that's going and where we brought our products in the last 3 years. A little bit of a lag. The picture I'm showing right now is a traditional ASRS where you have a crane type base system storing pallets. And what I'll be focused today on is talking about pallet storage and retrieval. The benefits to ASRS systems, you can get higher throughput in your building, increase your efficiencies, increase safety, reliability, reduce your human error, and reduce cost. Most of these buildings, some of these buildings have rack supported buildings where they're building the entire rack structure up and putting the roof on it. Most of the time they're putting into a traditional type of warehouse to try to fit them into that warehouse. The problem with this is really ASRSs benefit large operations and companies that can afford to put in a large ASRS system or have the need for that type of large system. But very large projects to do this takes multiple months or years to even get these systems into the operations. No. These ASRSs typically, like the one I'm showing on the right here, are complex and lengthy in deployment. So they could take from planning side, 8 months to a year and a half to actually get one of these up in operation. Very inflexible, where they have the, in this case right here, they have the cranes within the aisles. And if you want to go from bay to bay, you have to basically bring the product out, bring it back out to the conveyor system, bring it back in or out. So very inflexible from that side, where some of your storage is within those bays. Still, inventory inaccuracy with this, because you have a lot of handoffs. You're taking from a crane system, dropping it off to conveyor sections. You still have inaccuracies within it. High capital expense. Some of these systems are $40 million, $30 million, up to, one I know about, a little over $100 million. So very expensive systems to put in place, and really out of reach for the small operations that are out there today. I was doing a little research yesterday. There's roughly 18,000 or so warehouses in America right now. And when I looked at my study this of what size warehouses really could use automation, it's very few that could, in that 18,000, that can use a large ASRS system, where if you can imagine taking a mobile system and actually utilizing that, there'd be much more opportunities in the marketplace for that. And, product availability issues. So if you have, if you want to get to an item that's in an aisle or in that row area, and if you have issues with your crane, some of these systems have dual crane systems, but you could lock out your need to get to that. And that's really key today when you think about the need to get product to the consumer or the store even faster. You think about today where people will order online and they want it, that day. Could be some food where they want it in 3 hours, 4 hours, or they want it the next day. So having product availability is really key to hit that speed and to get the products out to the consumer or stores, or if you're feeding a manufacturing line, same thing from that standpoint. Like I was saying, these systems are pretty costly, 40 to 80 million bucks for some of these systems, or could be even higher. So the solution I'm going to talk about today is and there's a big theme here in this webinar here about AMRs, is, can you imagine if you can take an AMR with the existing technology you have today and actually utilize that for high bay picking, and actually that high bay system would be part of the rest of your, whether you have tugging, pallet jacks, pallet stackers, whatever you have within that technology. If you can bring that all together, and if a system had inventory management, where it's key for this, right? Or even inventory awareness, and take that mobile, autonomous robotics and bring that all together. And that's really taking an ASRS and from an automated ASRS to making it an autonomous ASRS. So what I'm bringing up here today is, utilizing, especially if you have a module platform where you have a one base robot, just like, for instance, a UR robot, where they have a robot and you can put different end effectors onto it or grippers onto it. If you had a technology where you have a base unit, just like a UR robot, and you can put different end effectors or adapters onto those, like a tugger, or a pallet stacker, or a high bay, or a car mover, or a pallet jack. And you can mix those products within your facility. That really goes a long way. And utilizing AMR technology, you can actually move a product. If you have to get a product from one place to another, you can utilize multiple different paths to get there to increase your efficiency, increase your throughput, and also your availability of the system. And the technology also works with existing rack and pallet systems. So by taking an AMR and putting the latest technologies and machine learning into it, you can actually utilize, like I'm showing here, a rack system. You can keep your same rack system you have today. You don't need any type of guides or anything else like that to hold your pallets. And so that really increases the speed at which you can bring a system online, but also it decreases the cost. And our big theme right now is AMRs, so it's mobile, not fixed equipment. Okay, so you can move your assets around and utilize those assets more effectively. You can also start, say if you had, a 1 million square foot warehouse and you had 3 or 4 bays that you wanted to start with, you could implement an ASRS system, an autonomous storage and retrieval system, in those areas that you want to start with, and then you can start moving out. You don't come in with a traditional ASRS system where you're going to come in, you're going for it, you're going to build it out. You can't start small and then expand by just adding more and more robots into the system. So it enables a lot of these warehouses I was talking about in America, North America, and Europe, and eventually in Asia. But you can take these and expand out as you grow your operation, or if you want to start off small and say, "Hey, I want to get understanding how AMRs work in my facility. I want to do real work with these," and then I could say buy four robots right now today. And then as I expand out, I get more knowledgeable about it, I get more use cases, more workflows in my facility, I can start building out from there. So the first part of is the warehouse management system. So what we've come up with is the smart fleet controller and inventory manager. So we call it here at Autoguide SurePath. Well, we developed SurePath about 3 years ago, looking for the future of where warehouses, manufacturing is going with what they want. Some things we thought about them was, hey, these AMRs are cool and all that, but wouldn't it be great if you had inventory manager, inventory aware, where I can say I had 20 instances of product, and then I can decide based on rules that the warehouse gives me via the WMS, I can decide what product I'm going to pick and when I'm going to pick it. Or some of these warehouses don't have inventory manager at all, and I can do that service for them. So that was a big feature. So I made an announcement yesterday about our new ASRS system, mobile ASRS system. And that was a real key function where some facilities don't have proper inventory manager. So I'm getting the power of it from what I want from an efficiency standpoint, a throughput standpoint, but also they're getting an inventory manager to give more accuracy for their products. And then in these facilities, you have a manual forklift, is what I started out with, what Autoguide is to develop that product. I'm going the wrong way. That gets replaced, with an AMR pallet stacker. So you can autonomously pick pallets. You can take those, not only warehouses, but you can take them from a manufacturing line. If you do a manual product building of pallets, or if you have a cobot building pallets, that product right there will interface with that. Once the product is finished, the pallet's finished, we'll come pick that pallet, bring it over to a stretch wrapper, to the dock, or to a tugger with trailers that want to move. And that's the next one. So a tugger. So if you can imagine a warehouse where you have buffer loads coming in, pallets coming in, you would take it off the dock, drop it onto a tugger, where if you go to our website, you can see us tugging 4 different carts with 8 different pallets on them. The pallet stack would take the product, put it onto the tugger, 8 at a time, do mass hauls into the warehouse, and then at that other side, you would have a high bay. The high bay would then pick it off the tugger, store it away, reverse process back. You have an order. The tugger, the high bay actually picks it off the rack, brings it over to the tugger. It's in queue. It hands off the pallets. The pallets then go to the dock. The pallet stacker then takes the pallet and then drops it off to the load zones. Other applications for this we're doing is from you could have, some manufacturers have the warehouse attached. So you could, from an AMR standpoint, the pallet stacker, take it from a cell that's doing work, building pallets. You take the pallet, you drop it off to the tugger, it does a long haul over to the warehouse. The high bay then takes it and then stores it away, and then the reverse process out to the dock when the orders come. So this really right here gives us the full complement of capabilities within that warehouse, or within manufacturing, or if you're going to do some buffering or some short storage before it goes to the warehouse. this system would allow you to do that. And you can start off small. You can build up small, start with a tugger, then go a pallet stacker, a high bay, or reverse that. You have these systems, and all you're doing is, we'd come in, map the entire warehouse, and all you're doing there now is adding on to that system. You don't have to put new infrastructure in or build up from there like you would with a traditional ASRS system. The benefits to an autonomous ASRS is allow small operation to gain efficiency of the larger operations. But I had a question yesterday. They were asking, hey, is this good also for large operations? Absolutely, it really is. But we saw originally that there's a big gain in operations that can't afford or don't have the time really to implement a large ASRS system, and they want the flexibility. But very applicable to smaller operations, but also larger operations. It gives you flexibility for business adjustments and seasonality. So with that module design, you can change out product if you need to, change out the adapters, just like you would with a robot with an end effector. And it dramatically lowers the cost of a traditional ASRS. You know, in not only cost of like the ROI when the system's operation, but think about that year it took to plan a major ASRS system where you can, and very quickly, implement an autonomous system. And that's really the big factor in, you know, mobile robots in general versus a conveyor type system. Lower operating costs, and again, you can start small and grow as the business grows. And our goal, you know, is an ASRS for all operation sizes, but you know, we never turn down the large operations either. The $2 million, $3 million square foot warehouses. You know, those are actually absolutely applicable to these operations, especially if you're taking the ASRS and you're feeding case pick systems or each pick systems. It's a key factor in this. The whole scheme of things in the warehouse in e-commerce operations. Thank you.
Rob, thank you very much. That was fantastic as always. We appreciate you joining us here today.
Thank you.
Next up, we have Andreas Boedenauer from CEO of AGILOX. Welcome. It's great to have you here.
Can you hear me?
I can hear you. How are you doing?
Excellent. Thank you so much, and thank you for having me.
It's a pleasure. Hold on one sec. I'm gonna fix a little issue here on my computer before we begin. That's been causing us some headaches. Hopefully not to the users, but just a little pruning maintenance here, just to make sure everything runs efficiently. All right, I'm gonna load you up here, and then we'll get going. All right, you should have screen control. Take it away.
There you go. Sorry about that.
Yep.
Okay. So we're going to do a little experiment here because we tend, in this circle, we tend to use a lot of specific words and abbreviations. And I realized in the last couple of years here when it comes to autonomous mobile robots, sometimes the user is not really, you know, aware of what really these type of abbreviations mean. So when we get into this use case, I would like to have some definitions cleared up beforehand. And please forgive me the, you know, tech insiders that at some point I try to kind of make it easy digestible to the outside world. So typically when we talk about AGVs, those are, of course, guided vehicles based on a predefined route using, you know, wires, rails, you know, any kind of optical guidance and this kind of thing. So it was a predefined route, and it was hard to change the route because of all the requirements. The newer version, well, this is actually, what's interesting, this is actually done in the 50s. So we are talking about a 7-year-old technology here. AMRs, so the AMRs came on when computer just really got, you know, Internet of Things and everything got computerized. So nowadays, I consider an autonomous mobile robot is a modern version of an AGV, but essentially still an AGV. However, it no longer uses and is bound to any predefined fixed routes, but with the vision system, it's either laser-based or vision-based navigation. You don't need to have any markers or any rails or any wires. So this is what we call internally here autonomous mobile robots, which is actually a modern version of an AGV. Now, what we get into now is what I present in that specific use case is an enhanced autonomous robot version, because now I would like to introduce you a completely new version of AMR generation, which is a swarm intelligent driven setup essentially. So that means we are using artificial swarm intelligence in order to fulfill those different work orders. We do not need, or we do not use any centralized fleet management system or server. So that means the intelligence lies into each individual unit. And those, in that case, we use forklift-based autonomous robots, so forklift-based pallet movers, essentially. And those pallet movers or those autonomous mobile robots use collectively shared information to make decisions and execute them independently. Essentially, if you have 10 units in your shop floor, warehouse, or manufacturing facility, all 10 units contribute with showing the environment, essentially like navigation, Google navigation, that you see actually some traffic jam over there and you can actually avoid and use a different route. And so in that case, this is what we use. And so when a work order comes in, the route will be chosen based on the collective information and is essentially the most efficient or most or the least expensive route, because the calculation itself is done virtually. So instead of a natural way of swarm intelligence is usually when we use to look at a flock of birds or ants, how ants actually build their own highways. This is all based on, typically based on survival instincts, but we replace the survival instincts, of course, with objectives, strong objectives. And one of the highest objectives is the efficiency. So the least expensive route, the vehicle which calculates virtually the least expensive route will take over the work order and fulfill the work order. So this has very specific advantages. However, having said that, of course, this is a very cutting edge technology in which, AGILOX came up 4 years ago. And we had one of our customers in, let's say, early adopters was BMW Germany. And you're looking at a picture, by the way, it was very hard. You all have excellent presentations. I loved your presentations. And however, I'm kind of, down to one picture because it was a hard time to get it released by the customers. So this is essentially, we are looking at a warehouse, staging area, and bringing essentially material to essentially bring the materials to the assembly line from a staging area. And in that case, BMW is currently our biggest swarm or union with a total of 13 units. So that makes BMW just a very early adopter of this type of technology. So for us, sorry. I guess I did something bad here. Anyhow, so for us, what was the, just to get into the risk from a customer's perspective, to get into the risk and use a completely new technology, and why was the decision made? Well, one of the things is the speed of model change, which, speed of model change actually in production requires that the material handling process is in constant flux. So you have, new parts to be delivered to the assembly line, or, you're going to switch, you just put together separate smaller body shops. However, so as we all know, automotive is extremely fast when it comes to model changes and product changes. So they required a product, a robot, which can be reprogrammed easily. When we say reprogrammed, it's a mouse click. There's no need for the customer to use any specific outlandish, get into computer language. It's just a drag and drop by the mouse just to reposition or create a new pickup or drop-off station. So that was a key element, to have extremely fast changes in production, and that needs to be addressed within the material handling and the material flow within the manufacturing facility. Uninterrupted workflow. One of the key elements is that we do not use a centralized fleet management system. So that means a typical centralized fleet management system, if something happened, you need, at least you have to look into redundancy just to make sure it's not going to happen. If you have also, let's say, a single AMR going down, you need to replace it immediately, because this AMR is a very specific task to bring from A to B. So in our case, when it comes to uninterrupted workflow, since we do not use any centralized server system, the system itself, if in case one of the AMRs goes down, it raises the hand and says, well, I'm out of here, I'm done. All the rest of them, and in that case, you got 10 units essentially, or BMW 13, all the 12 other ones will take over and distribute the workload of the one just left, within the union. So essentially, we're looking into self-recovery modes that, when something happens, it's not the worst case scenario. Maybe you could slow down, the speed slows down a little bit in the material handling process, but you can prioritize, work orders. So if something has low priority, we just put it in the back, in the back burner, and then pick it up later. So that's the beauty of having artificial swarm intelligence actually thinking and self-recover the whole union. Of course, a key element is interoperability. We always face to have existing either other units out there, legacy products, or typically like automatic doors, fire alarm systems. So in case a fire alarm goes off, our unit goes to the side of the aisle and parks and be in a safe place so the aisles are free. We use open interfaces, and that was also one of the major requirements for BMW. We use open interfaces, JSON. It's not in any way a secretive internal software language. We use the JSON protocol, can be used by anyone, and we use that for interacting or interfacing with existing products and existing pieces of doors, whatever, in your facility. So energy savings, based on, one, of course, the key element is that in that case, I do not have a picture. Unfortunately, I should have made, way nicer this presentation, but our unit is extremely lightweight. So that was also one of the key elements, tiny spaces, narrow aisle, it turns on the spot. The weight is about 800 pounds and can carry actually 2,200 pounds. So just by accelerating and decelerating just an 800-pound unit without the load saves a ton of money in energy costs. So that means also the smart battery system, what we have on it, replenishes the battery when we drop the load, we lower the load, or we we do some deceleration or braking essentially to replenish. So the energy savings are, also, especially in Europe, when it comes to energy savings, a big part of decision making. Plug and perform, easy commissioning deployment. Again, this is especially with bigger companies extremely important, because with a simple and easy deployment, you can actually switch units between different unions in your different facilities. So if you have 18 different facilities in all over Europe or here in the US, you just pick one, and you have seasonal changes. So you need more of those AMRs in the other facility. You just pack up 3, assign it to the other unions, and you're good. So that means easy commissioning. They plug and perform truly is as simple as it sounds. You just charge it, you unpack it, charge it, turn it on. The initial teaching is done within minutes, depends of course on the size of your environment. And the rest of what we call commissioning really is training, to train the operator, because the operator will be the one who will do almost everything, because usually people fall in love with this unit and they want to learn more. So they soon enough, within 2 or 3 weeks, they get into an administrator's level, and we help and teach them to get into the administrator, to get him administrator access, and then they can change and do everything they want to. Having said that, so this is only for the first initially deployed unit. All the subsequent other units is not even 10 minutes, because you unpack the second unit, you assign an IP address, and it learns everything from the units already existing in that swarm union. So there's no need for additional teaching or training. Whatever new unit comes in essentially learns from the initial one or the other ones already existing in that union. So really, all it does is it comes down to cost saving. When we talk about, in general, what is autonomous mobile robots based on swarm intelligence, essentially, we are looking into all the factors we just discussed are really hooked into the swarm intelligence advantages. Since we do not use a centralized server system, there are no hidden costs in the future. Essentially, there's no need to have some IT person come in and reprogram or service your server, because really the operator can do it. The operators can do it themselves, all the way to administrators level. And in many cases, though, even the whole service and maintenance can be done, which, by the way, is also part of this use case, because BMW also took over the service and maintenance part, which is extremely easy to do. With the only wear and tear parts are the wheels. That's about it. Looking at a lifespan for these products of between 7 and 10 years. Essentially, the initial capital expenditure is marginal or can be marginalized. So that was, it all comes down to cost saving, and the swarm intelligence specifically leads to that, bottom line, that over a specific time period, looking at 5, 7, 10 years, of course, that's the initial cost is really, really marginalized. So that's essentially my spiel on artificial swarm intelligence, and why this is going to be a big factor in the future. I strongly believe that we get into swarm intelligence through the AMR, or the mobile material handling piece equipment, because it's an easy access. But just think of the future. We can even imagine that some part of the manufacturing machines get a little bit mobile with some wheels and can actually reassemble themselves. And that's just, in my opinion, the future for manufacturing as well.
Thank you very much, Andreas. That was great. We appreciate you taking the time to be with us here today. Josh, you're up next. How are you?
Yeah, doing great.
It's great to see you. I'm going to hand you control here, I think. There you are. It's a session with 12 people. I can't find where to give the controls to. All right, Josh, you've got it. Take it away.
Perfect. Thank you, Robert. So my name is Josh Cloer. I'm the sales director for mobile industrial robots, primarily focused on the eastern half of the United States. Also, our company is known as MIR for short. You may have heard that. Today, I'm here to highlight a specific use case for autonomous mobile robots within logistics. We chose to zoom in on an application, a use case within, primarily within parcel and distribution facilities, where there's a need to automate the transportation of non-conveyable or irregular items that are difficult to sort. Okay, so some of the other panelists here have highlighted, movement of pallets autonomously, and that's something that you typically think of when you think of large mobile robots in logistics. You think of them as pallet movers. So that being something that's been highlighted today, and something that we do on a regular basis. There's a lot of information out there about it, so we chose to highlight something different, but really pallet movement is a huge part of what you can do with large mobile robots, platform robots, and also forklift autonomous mobile robots. And this provides a more flexible way to solve various workflow challenges, and offers a huge upside overall in terms of automating the pallet transfers and pallet movements within a facility. But today I want to answer the question, how do you automate the transport of larger goods that are not on a pallet and cannot be sorted in a conveyor system? Because that has been challenging in the past. And really want to start out with some definitions, define the problem. And what we see in distribution centers and primarily in the parcel industry, in the parcel space, where you're sorting packages and items out for distribution to commercial spaces and out to residential spaces. We see that there is a need to automate the movements of non-conveyable or irregular items. And what is a non-conveyable? What is an irregular item? That really means it's a package or an item that cannot be processed by an automated system, typically due to an irregular shape or its very large size. So it cannot fit on a small conveyor for whatever reason. And we see that with the increase in e-commerce and really the increase in moving and selling larger goods in e-commerce, that this increased dramatically, and also increased dramatically the need for shipping irregular goods. Even today, with the crisis that we're in, this has increased much more because more people are staying home and less people are going out into retail spaces to purchase goods. So this is being shipped through distribution centers. And the current methods for transporting these items is typically manual and time consuming, and thus it is costly. So we want to try to solve that problem, but first let's look at how is it done today. So today, typically what you see is the non-conveyables are loaded, after they come into the distribution center, they're loaded manually onto a central, very wide conveyor that you can move the larger items on. And they're semi-processed. There's pictures taken of it so that you can know where this needs to go from here. And then it is manually taken off of the conveyor and sorted into carts, and then typically put into a train of carts and pulled by a tugger, a manual tugger. So an operator drives a tugger around, pulls this train of carts to distribute to different dock bays, and maybe it's to a wing of dock bays and down another large conveyor to then you have personnel that are taking off the parcel one by one and taking it to the right dock bay, or maybe sometimes the cart will go all the way to the dock bay. But ultimately, this process is dangerous. It's inefficient, and it's also very error prone. A lot of times the pieces will fall off the carts. You'll put the wrong thing on the wrong cart, and this really could be done in a better way. and rather famously, actually, in the past few years, this has been automated. At least the movement part of this has been automated. So using an autonomous tugger, this has been tested and deployed. And this does solve much of the need and improve the safety and efficiency of the operation. But ultimately, I would like to challenge this application a little bit to be better, because there are some drawbacks in this application with autonomous tuggers. Ultimately, the carts are fixed to the tugger, and there's no automatic decouple, and there's no automatic transfer of the cart away from the tugger in some way. So ultimately, the most expensive part of the setup is stuck to the carts, and there has to be personnel waiting for those goods to be taken off of the carts. So this makes it costly to do with this, and also means that the autonomous tugger cannot move on to do other things in the space. And speaking of space, there's also a large spatial requirement for this, and typically, these are brownfield deployments. They're retrofitted into existing infrastructure, and in that case, the infrastructure wasn't designed to house an autonomous vehicle. So it's something that needs to be evaluated and looked at. Is there enough space to actually do it in this way? And also, you see that it's primarily following a fixed path. There are some recovery mechanisms with tuggers, but all of the safety equipment is typically on the device itself and not able to look at the carts that are behind the tugger. So it can't be as dynamic and really have a true dynamic path planning algorithm to go around objects in real time. And the floor space is really important to be flexible in these environments as things are changing day to day. So I want to highlight the case for really platform-based autonomous mobile robots in this space. There it goes. So it's a GIF, so it'll loop around. But really, these are mobile robots with a 0-degree turn radius and some sort of cart attachment mechanism, so that it can come underneath the cart and take it away. So you can then autonomously pick up and drop off carts. So you still have the manual loading of the cart itself. So you would have the operators take the large non-conveyables off of a conveyor and off of a sortation area, a larger sortation area, load it onto a cart, and then stage it for this mobile platform robot to come underneath, grab it, and take it to where it needs to go. So this really has some key advantages in terms of flexibility and also how it can decouple from the cart so that it can go and do more work. Robert, I don't know if you can help me there. I'm just trying to get to the next slide.
Yeah, it looks like looks like my PowerPoint is glitching here a little bit. Hold on one sec.
Okay.
I will see if PowerPoint hasn't crashed on me yet this entire week. We're about,
I threw a GIF in there, and I think
I know that's what did it. Let me get you here. No, that didn't work either. Hold please. All right, we're back to here. Let me go forward. There, we were there.
I can go on to one more.
Yeah, it does. It is. Yeah, it is not happy with me, Allison. That spinning blue circle is the best part of this. Oh, and there it crashes. All right. Oh, let me try to reboot it here and see what happens. If you've got PowerPoint crashes on your RIA bingo card, that's where we are in the program. All right. Hold on. All right. The GIFs are causing a little headache here. Let's see.
See if maybe it's just that slide and we can go directly to the next slide potentially.
Yeah, we may have to. I think there's something it's not liking about that. Oh, there we are, I think.
Okay. Yep,
I don't know if you'll be able to advance off of this slide now, but you're here, so.
Okay. I don't know if it'll move or not, but it should show the robot driving around, but that's okay. You know, ultimately the robot is much more maneuverable because it is actually underneath and has the zero turn radius. So it's much more well equipped to be retrofitted into existing infrastructure where you have tight spaces. So it can really solve a lot more of the needs. There's no fixed path with this type of technology because it has all of the safety sensors to where you can see 360 degrees around the robot with various sensors. So you can actually account for the card on top, everything that's around it, and in real time make a path that is going to find its destination, even when personnel or other vehicle traffic get into the way. So it can safely travel in space with a lot of the existing infrastructure, the same personnel, the same vehicle traffic. And ultimately, you can also autonomously charge during downtime. So you can run for a certain amount for the shift and then go to charge for downtime.
Yeah, it's official. It hates you. let me see what I can do here.
There's only one more slide, so we can just launch straight to that one. Maybe that'll work. There we go. So these devices are inherently connected, so they can work on your existing Wi-Fi networks. They can be managed, programmed, controlled from there, and ultimately, it's an easy-to-use platform that is really designed for the everyday user of this equipment. And since it's connected, we might as well take advantage of that. It can be connected to your WMS system, your ERP system, other management systems, and really allow the facility to create orders on demand, provide real-time data about the productivity of the system, and really be utilized, really allow those systems to be utilized much, much more in a physical way. So if you have this problem and you're considering how to solve it, I think that the platform mobile robot with a card on top is a great solution to be retrofitted into these large distribution centers for sorting large, irregular, or non-conveyable items. And that's it for me, Robert.
Josh, sorry about that. I appreciate
okay.
your good-naturedness as always.
Absolutely.
As I
Thanks,
said,
Robert.
Yeah, thank you. A pleasure as always. And next up, we have Karen Leavitt of Locus. Perhaps the PowerPoint, the powers that be over PowerPoint will treat her better. Karen, can you hear me? Karen, are you there? Can anyone hear me?
Yes.
Hang on, I got to unmute. All right,
there you
hang
go.
on. I think I was muted. There I go. Sorry.
Perfect.
All right, great.
The joys of an online virtual conference, right? It's like all the things that can go wrong.
Could I throw one more wrench in, Bob, because I'm actually logged in twice? Could I ask you to toss the PowerPoint control to the other me, please?
Yes. You really want to increase the degree of
hey, you know what? We gotta, if you want the East German judge to get to give you her vote, you gotta do something really spectacular here.
All right.
So.
All right, you should have it now, I believe. So try moving around and see if it works for you.
Let's see. I don't think I do, but
it looks like it advanced.
See.
Try hitting your keyboard.
Yeah, but I don't think that was me. Let's see. I'm not seeing a control for it.
Yeah, try moving the mouse and see what happens.
I'm moving the mouse.
All right, let me try something else here. The joys
I'm seeing your mouse, but
yeah. All right, let me try again here. So it's the one that's lists you as a presenter, right?
Exactly.
All right, try again. It's not.
All right, trying now. I don't see the control thing. Well, you know what? Let's. I see your mouse moving.
Yeah, that's me. it says it's waiting on you. Doesn't seem to be. Are you on an iPad or?
No, I'm on it. This is actually a desktop, so that's why I wanted it to be on this one. Let's see if there's something I need to do here to accept. There's no message inviting me to do anything.
Yeah, you should just have it. Let me try again here. It's also possible I'm behind one of your windows as well. So
let me take
I hope your attendees love how the sausage is made here.
Yeah, I really, really appreciate the audience's patience. You know what we're going to do here, Bob? I'm just going to do it on my iPad, which is the one that has the camera, because that's what it's got.
All right,
so
if that works,
we're going to do it that way.
If not, I will just yell out, and I will be happy to advance.
I'll holler
for you.
So great. So hi, I'm Karen Leavitt. I'm with Locus Robotics, and we make autonomous mobile robots that work collaboratively with human workers to do piece handling in the warehouse. We started out with piece picking, and now we also do put away, which has been particularly popular now that everybody's in lockdown and ordering everything online. And I thought, first of all, my co-panelists have done such a terrific job talking about the different technologies. I'm going to talk about something a little bit different. I want to talk about a more timely topic, which is what happens when the unexpected happens. And we've talked to a lot of customers in the course of the last 6-8 months who have said, well, we were looking at automation. We were planning to deploy automation in the near future. We thought we'd get it in time for this year's peak or just post-peak or whatever. And then, of course, this giant wrecking ball came and disrupted our lives. So, the disaster can strike at any time. And, of course, sometimes disaster also creates opportunity. So, hang on, this will be interesting to see what happens, because the control here is now on an iPad. So let's see how the iPad wants to deal with this.
Yeah, it doesn't. I'm not optimistic.
It doesn't.
How about I just advance you, Karen?
I'm just going to ask you to, if you could advance, go back one. All right, so just to frame everything, I know we all like to call it the new normal, and now that we've been in it for 6-7 months, it is the new normal. And of course, it's not normal. COVID-19 has changed the way consumers are shopping. And even I think when things return to something more resembling normal, I think a lot of their behaviors are going to stick. We've seen about 300 million Americans at one time or another have been under some sort of lockdown order in the US. And that, of course, dramatically drove up online behavior. We've seen 68%, or probably more now, because this is a little bit of an earlier number of online revenue growth tick up, about a triple-digit number of online e-commerce orders. And when people come to websites, they are filling their shopping carts and they're checking out. They are converting when they come to the websites. And I'm sure you've all seen that. We have customers who are experiencing Black Friday style volumes every single day. You can click now. Bob? Robert? There you go. One of the things that's been kind of interesting here is items that people typically didn't buy online in the past are getting bought online. So online grocery was really in its infancy. Only about 3% of all grocery orders were taking place online prior to March. But we've now seen online grocery ordering accelerating by about 4 years. We're up to close to 10% now. So more than triple the penetration rate of online into grocery. And of course, some of that is going to revert back to in-person shopping eventually, but I think a lot of people are also going to stay for the convenience of it. And I found this kind of an interesting chart to show. I know it's a little difficult to read, but what it's showing is sort of the 3 phases of lockdown here. When people first took cover, they stocked up on necessities. So they got groceries, some exercise equipment, and some pet supplies. And then after they were in lockdown for a number of weeks, they started to indulge in, not really an indulgence, but they started to purchase coping supplies, hobbyist materials, or educational tools and toys for their kids as the kids started going into online schooling. And then eventually we've started to see some of the more discretionary items come back, things like beauty supplies, even some apparel, and shoes. So people are starting to get a little bit of cabin fever, and so they're starting to buy some indulgences. Click.
It's a little slow to advance on my end.
A little sluggish? Okay, not a problem. Well, this is going to be really fun when we get to the animated slides. So what we've seen in the effect on labor is we always had a labor issue in staffing the warehouse, but because there's now greater demand and the demand has been pushed upstream into the warehouse, even more labor is needed. And even though we know that there have been millions of jobs and millions of people put out of their jobs, they're not necessarily a match for the warehouse labor, either geographically or because they really don't want to expose themselves to the warehouse. So they're under quarantine. They don't want to change their line of work. Everybody's sort of hoping things will get back to normal. And the labor is getting more expensive to keep, not just so much in the wages that are paid to the labor, but of course we all have to implement social distancing and industrial hygiene measures in the warehouse in order to make sure that we're keeping our workers safe. Advance, please. So we still have the traditional challenges that we've had. E-commerce has still been exploding. It was growing at a 10% compound annual growth rate heading into this year. It's been a huge uptick. Even though e-commerce has been doing a 10% compound annual growth rate, in January, pre-pandemic, it still only represented about 11% of all retail spending in the US. In the quarter just ended, which was the first full pandemic quarter, it had jumped up to about 16% of all retail spending. So about a 35% uptick in e-commerce. Labor availability has gone from being a problem to a crisis. Customers have now, stopped forgiving us for getting things to them with a little bit more time. They're sort of expecting that warehouse operators have caught up. And so they're expecting now rapid fulfillment again. They still want to keep their costs low. We're seeing a lot more financial stress on our buyers. So all of what I'll call the Amazon effect figures have returned. Consumer expectations have returned to their very high demand levels. But there are some new things too. As I mentioned, health safety has now become a critical concern. And traditional seasonality is really thrown up in the air. We used to have customers who would have two major seasons. They'd have the holiday season, they'd have back to school. But what does back to school even mean anymore? Kids are staying home, school hours, if they're opening for live in person, are getting staggered. And we're seeing a lot more omnichannel behavior where people really need more flexibility for click and collect, for example. We're also seeing consumers, because they're transitioning from brick and mortar stores to e-commerce, doing a lot more bracketing of their orders. They'll order something in a size medium, but they might also order the small and the large at the same time because they're not sure which one they need. And that means that returns have dramatically upticked as well. All right, so click there, please, Robert, my mouse Sherpa. So a lot of people, I think, at the start of the pandemic, we saw sort of two different groups. Many of our customers called us immediately and really used this time as an opportunity to really advance the ball, to use this as a time to plan and get ahead. I think there were some people who sort of froze in their tracks a little bit and said, let's wait and see what happens. And of course, we've been waiting and seeing now for 6 months. So I think if the last 6 months have really shown us that it's critical to use this time to harden our facilities, harden our automation, to make sure that we're getting ahead and not just treading water. And as I mentioned, seasons are fluid now. So one thing that the pandemic has highlighted is the critical need for flexibility. the flexibility to expand or contract capacity on a moment's notice, or to reorganize your facility, or to address some macro challenges like social distancing and so forth. So flexibility, scalability, and nimbleness are now more important than ever. Click. So, you know, I've mentioned a lot of these things. As you prepare for the future, you obviously want to be able to deploy quickly, be able to have the nimbleness to scale up or down on a moment's notice. You want to make sure you're getting a strong ROI. I always tell people robots are cool, but cool doesn't pay the bills. You have to be able to see a measurable, hardened economic value proposition in order for the solution to make sense. And you want to make sure you're creating a work environment that keeps your employees coming in and working effectively without worrying about their health and safety. So click, Robert. And now we'll get into some interesting, there are going to be 4 clicks here. So you can click them all at once. 4 ways we optimize the warehouse we think are critical. Obviously, you want to drive up productivity. You want to make sure you've got the flexibility to reconfigure as necessary, constantly innovating and improving in a continuous improvement kind of way, and make sure that you're getting the insights to be able to inform and drive your business as you go forward. So how does that work? Now we're going to have a lot of clicking here, Robert, so let's click. So here's how our solution works. We're essentially replacing pick carts in the warehouse. We integrate with the WMS. The Locus solution obtains orders from the WMS. Stop clicking there for a moment. And then sends the orders to the robots. And what we're doing is we really want to maximize work density. So we maximize the density on the robot by combining multiple orders on the robot. And we maximize the density of the orders within the warehouse. And I'm going to tell you about a third density factor in the next slide. And then the robots travel out into the aisles. The robot will go to its first pick, and it will be met by the nearest available worker. That worker will pick and scan the item onto the robot. The robot will move to its next pick, and the worker will move to her next robot. If you click again, we can see that what's happening here is there's a large user interface in the form of a full-size tablet. It's actually an iPad that's giving the worker a lot of cues in the worker's native language. As the worker approaches, the Locus solution recognizes the worker and changes to that worker's preferred language based on their profile. And the robots are constantly informing the worker about what to do next, where to go, where's the next nearest robot, tips on where to find things, and they're doing error checking as well to make sure that the right items are being picked and scanned. And if you click again, you'll see that the key concept we've got here is what we call our multi-bot model. What does that mean? Click. It means that instead of there being just a one-to-one relationship between workers and robots, there are multiple robots for every worker in the warehouse. The ratio is typically 3 or 4 robots for every worker in the warehouse. And that means that a worker's effective capacity exceeds, is extended well beyond the capacity of a traditional pick cart in the warehouse, because the worker is filling up 4 robots worth of orders in the course of doing business. And this is how we're driving a 2 to 3x increase in productivity. So if we click again, we'll get to sort of how does this work. This is going to be a little bit tricky here. Imagine you've got products scattered through the warehouse, and click again twice more, I think. You'll see that, as I mentioned, we've got roughly 3 to 4 robots per worker, and the workers and the robots operate as independent agents. Click. That's really important. By separating the workers and the robots, we're dramatically cutting down on the walking time per worker, because the work is being brought to the associate. The robot is coming to the worker not just as a conveyance, but also as a bearer of instructions. So click again, and you'll see that in this particular warehouse, we already have a couple of workers there in aisle 3. And so the next robot up in the queue in the bottom right here, we're going to not only maximize the number of orders on the robot and gather orders that are closest together in the warehouse, we're going to choose orders that are closest to where we know there are workers. The next robot up, we're going to choose orders that are close to aisle 3. And the robot after that we want that robot going to aisle 3 and the robot after that. So click a couple of times here. We're going to flood the zone with robots going to the vicinity of aisle 3, and the worker who's closest to the robot is going to make those picks. So if you click again, you'll see that each worker is just making his or her picks to the nearest available robot. If you click one more time, I think you'll get that sort of star configuration. So a robot is interacting with any and all workers, and a worker is interacting with any and all robots. And the only worker in the warehouse responsible for completing an order from start to finish is the robot itself. And that robot is going to work with as many human associates as it needs to get the job done. I think a couple more clicks will show that what we'll do is the robots will sweep through the warehouse and sort of pull the workers along. And whereas a typical walk to pick ratio in most warehouses with carts is going to be about 80-20, this is how we get that walk to pick ratio down to about 50-50. And that's where we're doubling or tripling productivity. So if you click to the next slide and click one more time to animate this, you can actually see this is a time lapse of how this works. These are orders that are being processed over about a 3 or 4 hour period, actually maybe longer than that, but you can see the heat map here and the density of work that's being done in that area of the warehouse, and then it will start to move across the warehouse. The color of the bar is a specific robot, and the height of the bar is the number of picks being made in that area. And if you were to watch this rather mesmerizing chart all day long, you would see these picks sweeping across the warehouse and clearing things out as efficiently as possible. And we'll move on from this now, although we could watch it for a while. And just to highlight the fact, thanks Robert, that there are really 3 types of walking or time off task that's happening. There's the long walk in and out, what I call the Gazinta and the Gazauda, and that's completely eliminated. The workers are just staying in the aisles. And what's great in this time of COVID is because the robots are coming to the workers, our customers are now assigning workers to specific aisles and telling them to stay in their zones. So the workers are never crossing paths with other workers. There's a natural social distancing feature built into this. Into technology, the design point was productivity, but it turns out if you don't have workers crossing paths with one another, which improves productivity, you're also not having them cross paths with one another for social distancing. So we eliminate the long walk, we eliminate the zone transition, and then there's just the interpick walking, which is dramatically reduced. We reduced that about 60–65%. So again, this is how we're improving productivity. And if we click to the next slide, it might be, so this is just to recap what I've said here, which is, as you think about how to roll this out, you want to deploy the robots for your current volume and for your steady state, but know that you can ramp up or draw down as volume changes throughout the year. And that's what our customers routinely do. We work with our customers to plan the volumes throughout the course of the year. And I think if we go to the next slide, we're going to see an actual video. If you click one more time, this will be a video of Mike Nowell from DHL describing how they're using the robots to pick medical devices.
Our site is shipping medical implants for next day surgeries. We consider ourselves to have a zero defect environment. That means that we have to hit a home run every day and make sure we have no misses and we have on-time shipments.
Our customers are demanding shorter lead times, and that's how innovation comes into play. Locus Robotics has been a great decision for us because we have seen really good results.
And it improved our cycle time to get the product out the door on time by our service level cutoff.
We have seen a reduction in cycle times by 50%, which is key for e-commerce and retailers. We have seen productivity improvement by up to 200%, which again allows us to keep the same headcount but process double the volume.
Productivity rates that we had was about 78 units an hour, and we're currently picking about 150 units an hour.
And we have also seen a reduction in training time by 80%, which is also really good for e-commerce and retailers.
The innovation is very simple. It fit our model. It's helped us gain some very good numbers as far as productivity. It was easy to implement. It's easy to maintain. It's easy to train on. Our customer is seeing some better results of us completing our SLAs at the end of the night. This innovation has helped us be the change.
So I think if we click one more time, we're just about done here. Yeah, so thank you. So thank you for that. So that's, what's interesting about that particular customer site, and we have about 60 customer sites today, about 30 customers with 60 sites. Some of our customers have as many as 7 or 8 warehouses with us. And you can see it's not only the increased productivity, but it's the reduction in training times. And Mike mentioned that's a zero defect warehouse. That's a warehouse that gets an order in for something like a pacemaker or a hip replacement joint at 3 o'clock on a Monday afternoon, and it has to be in a surgical theater by 8:30 on Tuesday morning. So they are really working under tight and very exacting deadlines. So
Karen, I hate to cut you off, Karen.
No, I'm just going to say thank you very much for having us. LocusRobotics.com.
I appreciate it, Zari. Sorry for the little technical glitch there, but a great presentation.
No problem.
And we're going to roll into
Robert.
thank you. And we're going to roll into our final presentation of this session. Everyone has been great. We have Mark Messina, the Chief Operating Officer of the Americas of Geek Plus. Mark, welcome. It's great to have you here.
Hey, thanks, Robert. It's good to be here. So, as you said, Mark Messina, CEO of Geek Plus Americas, and Geek Plus is a new member to the RAA. So I'd like to thank you and the RAA for the opportunity to share our case study of our smart warehouse robotics. A little bit about myself. I'm originally from the Boston area with about 20 years in engineering operations and product development experience. And my background includes robotics R&D and factory automation, medical robotics, delivery drones, and warehouse intralogistics systems. I've been involved heavily in AI intelligent robotics for the last 7 years, and I joined Geek Plus late last year to lead the Americas market. Thanks again for your time to share this case study of Geek Plus with our partner, Nike Japan. So who's Geek Plus? We're a global technology company with 850 employees and offices in Hong Kong, Singapore, Taiwan, Japan, Germany, UK, America, and China. And we're China's first robotics unicorn with over $430 million in VC investment to date. About half of our 850 employees are R&D engineers who come from leading technology universities. And so we have very deep capabilities in artificial intelligence, machine learning, hardware and software development, and manufacturing. We're so into robots that we use our own robots to manufacture up to 30,000 robots per year in our own smart factory. And though our robots often take the spotlight, our real magic is the AI platform that orchestrates the movement of hundreds of robots, thousands of racks, and millions of pieces of inventory without a single collision or lost piece. We focus on developing solutions that automate the tasks that humans aren't particularly good at. And in doing this, we've literally inverted the normal warehouse operations. Instead of humans walking up to 15 miles a day to get inventory, our robots bring the inventory to the human. We let robots literally do the heavy lifting so humans can do what they do very well, which is navigating the complex physical movements of picking inventory. Even though you and I don't think twice about it, the simple act of picking up an object requires tremendous computation and sensing ability. So we like to think of things a bit like going to the grocery store to get something, excuse me. You'll spend most of your time navigating the store, and if you're like me, you'll be searching for the right brand, looking at other products, buying stuff you don't need, et cetera, et cetera. And actually, only a short part of the whole trip is spent handling the thing you're looking for. And you'll be lucky if you get the right item by the time you leave. Humans are really good at handling geometrically complex objects, much better than we are at finding objects in a big, ambiguous open space. The key here is our robots free humans to do the work they naturally do very well and efficiently, and we let the robots do the other tasks. So today, I'll share with you our case study of the Nike Japan Automated Distribution Center. As you know, Nike Japan is a leading sports apparel retailer. Well, Nike wanted to provide their customers in Japan with same-day delivery and introduced the tagline, "Dreams shouldn't have to wait," to go along with it. As a leader in the apparel industry, Nike knows that customers have come to expect this level of service, and it's a key market advantage. So the Nike Japan team had a hard look at their existing operations to see if there was any way they could achieve same-day delivery. The operations were standard operations and not flexible, efficient, or adaptable. And as it turns out, they couldn't deliver same day, so they reached out to us. So the solution that I'm presenting today is our goods-to-person system. And in this picture, you can see our silver P-series robots with their blue lights on, sitting underneath the inventory pods, which are the racks with the corrugate bins. Each robot is about 2.5 by 3 feet, and the racks are about 9 feet by 3 feet by 3 feet, just to give you an idea of what we're talking about size-wise. So what you're seeing here is a small part of a very large, very dense space that we call the storage field. Each of the 4 sides of the field is lined with workstations where the operators stand. In this image, you don't see the humans because they're busy at the workstation, standing on a comfortable work mat, ergonomically picking product at a few hundred picks per hour. We even gamify the UI so workers can compete against each other. Here's a little video that will give you a better idea of the system in operation. So here you can see a robot that was dispatched to collect a pod that has items to be picked at the workstation. In order to avoid traffic, the robots can travel under the pods to take the shortest path. So the field, to an unloaded robot, it looks completely open. Once it reaches the target pod, it lifts it and carries it to a workstation where a touchscreen is displaying the bin location to pick from and a large picture of the item to be picked. The humans pick the item, scan it, and sends it along in the fulfillment process while the robot leaves to put the pod back in the field. So you can see how this method improves picking rates from a traditional walk, hunt, and find rate to a very high pick as quick as you can rate. Also, with secondary scanning, we get virtually 100% item pick accuracy. So that's the operation for one item being picked. But behind the scenes, the AI platform is simultaneously optimizing hundreds of orders and the path of just as many robots to ensure no bottlenecks or idle time for the humans or the bots. Can you advance? Sorry, we're not seeing. So as I mentioned, our focus at Geek Plus is automating tasks that aren't improved by human ability. We eliminate miles of daily walking and increase order pick rate for Nike Japan from about 100 picks per hour to well over 300. And actually that number improves as our system learns and adjusts based on the day-to-day operating conditions. The Nike system consumes much less electricity and requires much less cooling than a standard DC. This means higher efficiency and more comfortable workplace, which translates to higher employee retention and fewer workplace injuries, and that reduces employee turnover. Aside from the obvious improvements in human resource utilization, we also have very high density storage, meaning better use of that expensive building. We aim to use every cubic foot of space, and our system optimizes the inventory at the bin, pod, and field level. To do this, our AI decides, based on specific item demand, how to store all the stuff. Do we mix items at the bin or pod level, or we make those locations all the same item? The system optimizes this automatically, and the AI is always moving the inventory, doing a real-time heat mapping behind the scenes to put the right inventory closest to the workstation so robot trips are short and we keep the pick rates high. The AI is also looking for order patterns. In most cases, we'll randomize the inventory in the field in order to distribute it so that it's always closest to a workstation. The software is also in the background doing a friends and family analysis. For example, a particular shoe might often also be ordered with a particular set of shorts. Software looks for these patterns and stores the inventory in the same pod so we get 2 picks at the same workstation. We even bury slow movers and send robots to dig out a pod. We do this so that we can press the inventory into an area, eliminating highways and slow moving zones. We're considering inventory pairing, density, picks per facing, distance to the workstation, traffic, queuing, order assembly, batching and waiting, battery charging, and order prioritization all in real time. There's a lot going on behind the scenes, but you get the idea that our AI is playing a massive numbers game all the time. Nike Japan has nearly 100% order accuracy. Think about that. With Nike, nearly every item looks the same. It's a red box with a swoosh. How to tell which shoe model, which size we are picking with a traditional hunt, identify, and pick model. In a traditional find and pick system, humans are really inefficient at picking such similar items. The goods-to-person system solves this by presenting only the right shelf and the right inventory with visual indicators and confirmation scanning of the filled orders. So the next reason Nike selected our solution is that, in a word, it's flexibility. Today, flexibility is king. E-commerce today is extremely dynamic. Customers are mercurial. There's flash sales, seasonal changes, holidays from multiple countries, changes in shipping carriers and routes, and on and on. Prior to intelligent automation systems, DCs were designed around what I call heavy iron. Huge systems built on core elements that are literally bolted to the floor. Conveyors, sorters, racks, pick mods, and lots of space dedicated to infrastructure and egress. How do you change a system like this when it's literally bolted to the floor? Well, the simple answer is you can't. The system at Nike Japan is dynamic and flexible. It easily adapts to changes in the business, and it does that mostly on its own. With traditional systems, the whole machine pretty much runs regardless of demand. With goods to person, we consume less energy and have lower operating costs since we only operate the components that are necessary. But we can also adapt to entirely different products. Let's say today the system is handling primarily footwear. What if tomorrow Nike Japan business changes and they start shipping mostly smartwatches or shirts instead? It's no problem. The system is easily reconfigured and adapts automatically. You're shipping globally and needs to sort to multiple doors today? No problem. We just reprogram the routing. So there's a lot of flexibility. Another point is our redundancy. Hundreds of robots are controlled by redundant servers, and the system has no choke points and no single points of failure. So the last point I'll share is that while our system at the surface appears quite simple, it's just bots and pods, right? The beauty of the system is that from an operator's perspective, life is really easy. There's a huge amount of math happening automatically in the background, and we have so many levers that we can pull. Every installation is like a fingerprint, and that's as unique as the business itself. But from the operations center, it's seamless. So to yardstick our efficiency, let's just say that traditional heavy iron systems require 18 to 24 months to design, deliver, install, and start shipping product. The Nike Japan system was up and running in just a few months. Our simplicity and flexibility shows up in faster go-live times and less headaches down the road when the business changes. Our bots are tracking when batteries, wheels, etc. need to be replaced, and predictive maintenance means operations has fewer emergencies to react to. As the e-commerce industry strives to shorten the time between a customer click and the product landing on their doorstep, fulfillment centers are getting physically closer and closer to the customer. And that means that a DC that's 30% smaller and twice as efficient is very valuable just from a land cost perspective. We don't dedicate much space to infrastructure or egress. The building is essentially all product. So combined with lower labor utilization, energy efficiency, lower equipment costs, the Nike Japan solution delivers results by reducing capital and operating expenses. And we see this trend happening more and more in the move to micro DC, where size, density, and speed are the only way to enable within the hour delivery, and that's coming very soon. So what was the result of our system? Well, the result is that with only 200 robots, we manage 150,000 square feet of inventory and can achieve 3 times labor efficiency and 2 times cubic utilization benefit. Smaller footprint, less labor, higher throughput, tons of flexibility. So yes, we hit a lot of important benefits, but the most important is that Nike Japan can provide customers same-day delivery in Tokyo. That just wasn't possible before. We really like it. Nike liked it so much they made a video, and I'll close our case study with a short version of it.
Dream your little dream, as small as it may be. Take your chance and dream. I know you'll see it through, though right now it might seem far away, like it's for tomorrow, not today. But I promise you, you're strong enough to
once again, I'm Mark Messina. Thank you for your time, and thank you for the RIA for providing this forum.
Hey, thank you, Mark, and thanks to all of our speakers in this session. I know there was a lot there in a really, really dense program. I hope you all appreciated it, though. I hope you really enjoyed this session. I know we are right at time, so I'm going to skip over the usual wrap up here. Others say we have a lot of great programming left here at the Robotics Week conference, but also, if you're interested in autonomous mobile robots and logistics, we have an upcoming fall event, the AMR conference, which you can find out everything you need to know about at robotics.org. Thank you again to all our panelists. We really appreciate you having here today. Again, I appreciate how dense this session was, and thank you all for your support. It was great having you all here today.
Thanks, Robert. Bye.
Thanks, guys.
Thank you. Bye.
Thanks, everyone.
Thank you.